Throughout the long history of Earth, mountains like these have been slowly worn away to look like this. Introducing Weathering and Soil, presented by Lalem and Legaspi.
Objectives. We will learn about describe types and processes of weathering, describe and compare basic soil types, learn the importance of soil conservation.
Hey Kate, look at this rock. It's smaller, but it looks like the same type of rock as this mountain. How is that even possible?
That's because of a process that can break large rocks into smaller rocks and eventually into much smaller rocks down further into soil.
A process? Can you tell me more about that process, Kate?
Of course, let's dig in and find out the process of breaking down or dissolving of rocks. What is weathering? Weathering describes the breaking down or dissolving of rocks and minerals on the surface of the earth. We have temperature, rainfall, and ice. There are three factors of weathering. We have physical or mechanical weathering, chemical weathering, and biological weathering. Physical or mechanical weathering. The breakdowns of rocks without a change in its composition is a process that causes the disintegration of rocks, minerals, and soils without chemical change. It's the process by which rocks break down or change shape and textures by external force, like forced weathering is the important form of physical weathering. There are three factors in physical or mechanical weathering. We have block disintegration. It is caused by successive heating and cooling, which causes the expansion and contraction of rocks. It occurs due to repeated expansion and contraction of rocks during day and night, causing stress on the joints of the rocks, which eventually splits the rocks into block. Foliation. Intense heating of the rock's outer layer is a form of mechanical weathering in which curved plates of rock are stripped from rock below. This results in exfoliation domes or dome-like hills and rounded boulders. And lastly, frost action. It refers to the alternate freezing and thawing of water inside the joints of the rock, like split into small particles or fragments, that breaks down rocks through the freezing and thawing process. First, water enters the rock through cracks and pores, traveling deep within the rock. As the water freezes, it expands into the rock, causing the cracks and pores to grow and exerts pressure on the walls of the rocks, thus breaking down the rock. Other factors of weathering. Chemical weathering. The weakening or disintegration of rocks and the formation of new compounds or new substances caused by chemical. There are three factors of chemical weathering. Oxidation, the process in which atmosphere oxygen reacts with the rocks to produce oxides. When oxygen combines with another substances, oxidation has occurred. Sometimes, a change in the color of a rock is an indication that oxidation has occurred. One common example of oxidation is rust. Next, we have carbonation. It's the process by which various types of carbonates are formed, like calcium carbonates, limestones, chalk, and marbles. Carbonation is the mixing of water with carbon dioxide to make carbonic acid. This type of weathering is important in the formation of caves. It dissolves carbon dioxide in rainwater or in moist air forms carbonic acid, and this acid reacts with mineral in rocks. Lastly, hydrolysis. It's a chemical breakdown of a compound due to reaction with water, like clay type. Is formed as chemicals in rock interact with water. In many rocks, for example, sodium minerals interact with water to form a salt water solution. Lastly, of the three factors of the weathering, Biological weathering. Biological weathering occurs when sometimes tiny plants may sprout up in and around broken rocks, and these sprouts turn into bigger plants. As they grow bigger, their roots start penetrating the rocks, particularly in weak spots or joints, and eventually the rock splits. It also caused by the movements of plants and animals. For example, a rabbit can burrow into a crack in a rock, making it bigger and eventually splitting the rock. It also caused by the living things, like plants, animals, and humans. The roots of the plants penetrate into the joints of the rock, searching for moisture, like earthworms, rats, rabbits, termites, and ants, breaking down the rocks through burrowing. They play an important role in the weathering of rocks, like agriculture, construction of the houses, and construction of the roads. That's all in the weathering process. How about you, Irish? What is the process of soil?
What about soil? Soil helps produce our food and unearth life-saving medicines and vaccines. Basically, soil is our life support system. But have you ever wondered what's the deal with the soil? I mean, look at everything around you. If plants came from a seed and birds came from eggs, what about soil? Where did soil come from? How was soil formed? But before we dig in with that, let us first define soil. A soil is the loose surface material that covers most land. It consists of inorganic particles and organic matter. It provides structural support to plants used in agriculture and is also their source of water and nutrients. Soil varies significantly in their chemical and physical properties. Soil is the upper layer of the earth in which plants grow. This is a black or brown material typically consisting of a mixture of organic remains, clay, and rock particles. Soil is classified into 4 types based on its texture. We have sandy soil, silt soil, clay soil, and loamy soil. Sandy soil is a sand type of soil. It consists of small particles of feathered rocks. Sandy soils are one of the poorest types of soil for growing plants because it has very low nutrients and poor holding capacity, which makes it hard for the plant's roots to absorb water. Silt soil is known to have much smaller particles compared to sandy soil and is made up of rocks and other mineral particles which are smaller than sand and larger than clay. It is the smooth and fine quality of soil that holds water better than sand. It is easily transported by moving currents and it is mainly found near the river, lakes, and other water bodies. Silt soil is more fertile compared to the other 3 types of soil. Therefore, it is also used in agricultural practices to improve soil fertility. Clay soil. Clay soil is the smallest particle among the other 2 types of soil. Its particles are tightly packed together with each other with very little or no airspace. Has very good water storage qualities that makes it hard for moisture and air to penetrate into it. Clay is the densest and heaviest type of soil which does not drain well or provide space for plant roots to flourish. Lastly, loamy soil. Loam is the 4th type of soil. It is a combination of sand, silt, and clay. It has the ability to retain moisture and nutrients, making it more suitable for farming. It has higher calcium and pH levels due to its inorganic origins. Soil is comprised of 45% of minerals, 25% of air, 25% of water, and 5% of organic matter. Soil is mostly made of big rocks that are slowly broken into smaller pieces. No matter how it happens, be it physically, chemically, or biologically, when rocks are broken, we call it weathering. Soil is crucial for many aspects, not only for us humans, but also for the animals. It provides habitats for animals and storage place for water. That's why we need to conserve and manage it. Come to think of it, what will happen to human life if soil wasn't conserved? According to former USA President Franklin D. Roosevelt, a nation that destroys its soil destroys itself.